Today we are going to be talking about logarithmic functions again. It says the definition of a logarithmic function. It says for x greater than 0 and b greater than 0 and b cannot be 1, then y equals log base b of x is equivalent to b to the y equals x. Okay, this is the ghost story I told you about when we were reviewing for your QB2, since this stuff wasn't supposed to be on them. And basically what it says is if you have some log of base b equals something, I like mine backwards because it's easier to roll the log. Wherever the log is, when you're trying to solve these things, if you, like let's say I was trying to solve this for x, that means I've got to get x alone, which means I've got to kill the log. And to kill the log, you don't really kill it, but you just roll it away. And what happens when you pick up a log? There's a bug under it, it screams and it runs and scurries away. Same thing. If you roll this log over, the bug moves over because he gets scared. But he's a bug, which means he always likes to be at the base of things. So when he moves over, he becomes the base for y, and x drops down. So I write mine backwards, but my x would drop and it would equal b to the y. All right, and then that's how you solve it. All right, so, whoa. All right, so first of all, it says changing from logarithmic to exponential form. They want us to write each equation in its equivalent exponential form. When they say write it in the exponential, they're saying get rid of the log, which means roll it over. So on my first one, I have 2 equals log base 5 of x. When the log rolls over, the bug moves over. So the log rolls over, the bug moves over and becomes the base of 2. And x drops. So x equals 5 squared, which means x equals 25, and we're done. Okay, on b, I've got 3 equals log base b of 64. They want exponential form, which means get rid of the log. So when the log rolls over, the bug moves over. So this becomes b to the 3 equals 64. So if I'm trying to solve for b, oh, sorry, I'm not solving. Sorry, it just said write them in exponential form. Sorry, you're done. They don't want you to actually solve them. All right, for c, I have log base 3 of 7 equals y. If they want exponential form, they are telling you to get rid of the log. So when the log rolls over, the base moves over. So 7 drops, and I have 3 to the y. And we're done. We're not solving them, we're just rewriting them. All right, so you do this one. Come back when you're ready. And hopefully you got 4. When the log rolls over, the base moves over. So 25 drops, and I have the bug becomes the base on the other side. All right, try this one. Hit pause, come back when you're ready. And hopefully you got 2. When the log rolls over, the bug moves over. So 64 drops, and the bug becomes the base on the other side. Okay, so now going back from exponential form to logarithmic. Okay, they're giving us exponential, and they want me to translate it into logarithmic form. And all you got to do is put the bug back under his log at the other side. Whatever's on the bottom of the exponent is the bug. So what you do is you come back to the other side and you roll the log back in place and stick the bug underneath it. And then everything else stays the same. 2 stays on this side, x stays on this side. Done. You're back in logarithmic form. Okay, so the middle one, my bug is b. So I'm going to put the log back on the other side, put my bug back under him, 8 drops, 3 drops, done. Okay, on the third one, my bug is E, so I'm going to put him back under his log. Actually, E's don't go under logs, E's go under natural logs. And everything else is going to drop. Y stays on this side, 9 stays on this side. All you're moving is the bug back under his log. And if your bug is an e, it has to go under a natural log. Done. Alright, you try this one. Hit pause. Come back when you're ready. And hopefully you got 4. Alright, my base or my bug is 3. So on the other side with 1/9, I put my bug back under the log. The 1/9 stays where it is and the -2 stays where it is. Now again, they write it backwards, but this side equals that side. Try this one, come back when you're ready. Little hint, get out of the radical. Alright, so if I get out of the radical, that's going to be 64 to the 1/3. Okay, which means my bug is 64. So I put him back under his log on the other side. 4 stays, 1/3 stays. Okay. Alright, try this one. Hit pause, come back when you're ready. And hopefully you got 1. Alright, my bug is C. So back on the other side, put him back under his log with the 5, 12 on this side, and the 3 drops down on that side. Cool. Alright, so how do you write logarithmic equation in exponential form? If you have a log base a of b equals x, that's going to be b equals a to the x. And how do you write an exponential equation in logarithmic form? You're going to start with b equals a to the x, yes, and you're going to say the bug was a, so you're going to put him back on the other side under his log with b, and x drops down. Alright, so now basic properties involving 1. Anytime you have this and matches this, your answer is whatever's in the air. Okay, so when these match, your answer is the exponent. And anytime you log or natural log, I don't care what your base is, a 10, a chicken, a cow, a 5, if you try and take the log of 1 or the natural log of 1, you will always get 0. Okay, and the other properties are, if you can make these match, your answer is the exponent, and if these match, your answer is this. Okay, so to evaluate logarithms, break down x in terms of b, rewrite x using your breakdown. Once they match, the base of the log and the base of your rewritten x cancel, and your answer is the exponent written in proper form. Okay, so what the trick is, guys, is to make these two match. So I want to break 16 down by 2s. If I break 16 down by 2, that's 8, by 2 is 4, by 2 is 2. So I'm not changing anything except for the 16. The 16 I'm going to rewrite as 2 to the 4th, because 1, 2, 3, 4 2's multiplied together make 16. And now do you see they match? Once those match, they like cancel each other out, and my answer is 4. So again, in the middle, my trick would be, since my base is 7, I want to rewrite 49 with 7s. If I break down 49 by 7, I get 7, 7. So I can rewrite 49 as 7 squared. Now the trick is, you can't have them in the freaking denominator. They've got to be out of the denominator. So get out of the denominator. You can move floors by changing the sign of your exponent. So 1 over 7 squared becomes 7 to the -2. You can move him up by changing his positive to a negative. And now, my friends, they match. So my answer is -2. Okay, again here. Now this one's going to be tricky. They want me to rewrite 5 with 25s. Well, I can't break down 5 by 25s. 25 don't win a 5. It's a trick. If the base is bigger than what you're logging, then what the trick is look for square roots. In other words, isn't the square root of 25 the same as 5? It is. So I can replace that. Log base 25 of the square root of 25, because that's still 5. And again, it's a trick. When this is bigger than this, rewrite this using the square root of that. Try the square root. Sometimes a cube root, sometimes something else weird. Now, the thing of it is I can't, these have to match. Not, this is a square root, this isn't. So get out of the radical, which would be 25 to the 1/2. 1 is the numerator, 2 is the denominator. And now they match, so I can cancel, and my answer is 1/2. Again, here, the trick is to get out of the radical. Okay, so log base 2 of 2 to the 1/5. And these already match, so my answer is 1/5. Now, what are you going to do when you can't make a match? Well, we'll learn that in a few days. But for right now, the trick is to, when you're solving or evaluating logarithmic functions, is your job, the only technique you have right now, there's more, but the only technique you have right now is to make these guys match. If you can't, there's other techniques, but I'm going to teach you those later. All right, so you try this one. Get out of the radical first, then you'll see it. Hit pause. Come back when you're ready. And hopefully you got 1/2. And yeah, if I get out of the radical, that's 11 to the 1/2. So if I have log base 11 of 11 to the 1/2, these match, and my answer is 1/2. All right, try this one. Little hint, the cube root of 8 is 2. Come on. All right, so hopefully you got 2. Yeah, I would rewrite this 2 as the cube root of 8, because the cube root of 8 is still 2. Then I would get out of the radical, which would be 8 to the 1/3, log base 8. And now these match, so my answer is 1/3. Okay, you try this one. Hit pause. Come back when you're ready. And hopefully you got, come on, negative 1/2. All right, the first thing is I want to get out of the radical or denominator, whichever one you want to do first, doesn't matter, but I got to do both. So I'm going to get out of the radical. That's going to be 3 to the 1/3. Now I'm going to get out of the denominator, move him up, which changes his sign, so that's going to be 3 to the negative, 1/2, not 1/3. Sorry, it's the square root. All right, so now these match, and my answer is negative 1/2. All right, so on these ones, again, do these match? Yes, then my answer is 1. Any log, I don't care what the base is, log of 1, natural log of 1, log base 10 of 1, I don't care. This is always, always, always going to be 0. All right, you do this one. So pause, come back when you're ready. Any log of 1 is 0. Okay, you try this one. Pause, come back when you're ready. They match, so my answer is 1. Okay, when they have these, you see how this 4 matches this 4? Again, my answer is 5. When these match, they cancel, and my answer is 9. Okay, try this one. Hit pause, come back when you're ready. And you should get 14. These match, they cancel, 14 is my answer. Try this one. Hit pause, come back when you're ready. These match, so my answer is 19. And we already talked about those. So we are at homework, which means we are done. So happy homeworking, and I will see you next time.